guys. Last lesson of the year. Be excited. Alright, so try this. How many outcomes are possible if you flip a coin 3 times? What do you guys think?
2 outcomes.
So there's how many outcomes possible if I have a coin, say I have a quarter,
2.
and I flip it 3 times. There's how many?
1 out of 3. Oh, wait, 2.
We're not talking about our chances. We're just talking about how many different outcomes can I get.
2. 3. Get head. Get tail.
Well, those are my options, but I'm flipping it 3 times. So I can flip it 3 times, and I can get heads, 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 right?
Tail.
Or I could get heads, heads, tails.
Tails, heads, tails.
Or I could get heads, tails, heads. Just write down what I read. Or we could get heads once and tails twice. Those are all the possibilities with having the head side first. Alright, if I have tails first, I can have tails, tails, tails. Or we could have tails twice and heads once. We could have tails, heads, heads. Or tails, heads, tails. Those are all my possibilities. Okay, that's if I'm flipping it 3 times, these are all the possibilities I could get. That's how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8, right? We all agree there's 8 possibilities. What we are going to be doing today is we're going to be using this algorithm to figure out how many outcomes without doing it hand by hand or step by step. Okay? So let's do it this way. Jeffrey, there's how many different sides on the coin? 2. And I'm flipping it how many times? So I can get, I flip it 1 time, I flip it again, I flip it again. I have 2 options both times, or all 3 times, right? 2 times 2 times 2? Let's see, times 2. Times 2. So I have 8. Do we see how these are the same? Okay, so that's what we're doing. We're basically taking, it's called the fundamental accounting principle. If one event can occur in a certain amount of ways, and another event can occur in the other way, then the number of ways that both events can occur is multiplied, m times n. So let's say m was like the coin, and n was the amount of times we're flipping it. If there were 3 events, then you would have to multiply all 3 different things. M times n times p. This is not completely new to you guys. You guys did it in Math 8, which would have been forever ago, but you've done probability before. All good with this? Alright, a classroom has 30 desks. Let's imagine we have 30 desks here. How many seating arrangements are possible? So let's say that I had these desks numbered. Okay, Isaac's desk is 1, that's 2, 3, 4, 5, Jeremy's 6, on and on. If I want to know how many different ways I could move these desks, Isaac could be the first desk, or he could be second, or he could be third, all the way to 30. Does that make sense? So what we're doing here essentially would be 30 times 29 times 28 times 27, all the way down to 1. Write that down. Do you think I want you to spend time doing that on your calculator? Absolutely not. Okay? So we are going to learn something called factorial. Factorial means that you are going to multiply a number by every number before it. Multiply a number by every number before it. Your symbol for factorial is an exclamation point. Your exclamation point can give you an answer. So example A would basically be like, if it's 3 factorial, that factorial tells me I have 3 times every number before it. So that's 3 times 2 times 1. How do I solve that? What's 3 times 2? 6, and then 6 times 1. So 3 factorial equals 6. I want you guys to do the rest. I'll show you, because I don't want you to have to do 10 times 9 times 8, on to number 1. Grab your calculator and copy what I do. Jeff, are you with me? For 10 factorial, we're going to type in the number 10. Hey, Jeremy. Type in the number 10, hit math, go over to PRB. Mine says PROB. Depending on how new your calculator is, it may just say PRB. Means probability. And we're going to go down to number 4. Once you hit that, you're going to hit enter again. So you get this number. You should get 3,628,000. What else you saying? 3 million.
3,628,628.
I want you guys to do 0 factorial and 6 factorial. Has anyone done 0 factorial already? It's just 0. Wait, it's 0? It's 1. Did you type it in, Jeffrey, or did you just guess?
Okay.
That's a special case. 0 factorial is going to be 1.
How come 0 times 0 is 4?
Yeah, but if we have 0 factorial, we're not really multiplying by anything in front of it, so that's why it's a special case. It just stays 1. And then for letter D, what is 6 factorial?
720.
720. Okay. Does that make sense? If we wanted to find out how many different ways we could move 30 desks, you would type in 30 factorial. We're not going to do that. It's a super, super long number. All right, example 1. We are choosing 2 students to play in a duet. If there are 4 students auditioning, how many possibilities do we have of different duets? All right, so I like to name my people. A, what's the name for A?
Alice.
Alice. All right, A for Alice. B is what?
Ben.
Ben. What is C? Cat. All right, like Catherine. All right, and D?
David.
Anyone else? You already did two. Give me another name.
Dawn.
Dawn? Okay. So we have Alice, Ben, Kat, and Dawn. Right? Alright, good. These are my people. We are choosing 2 students to play in a duet. We all know a duet is how many people?
2.
Alright, good. So that means that I could have Alice and Ben. They could be partners for the duet. Make sure you write this down. Alice could also be with Kat. And Alice could be with Dawn. Alright. Ben could be with Alice. We already have AB, right? We don't have to write that again. So Ben could be with Kat. And Ben could be with Dawn. Right? Let's see here. Is Kat not with someone? Is Kat with Dawn yet? No, Kat can be with Dawn. We already have Kat and Alice. We have Kat and Ben. Alright, that's it. So I have how many possibilities here? 1, 2, 3, 4, 5. We have 6 possible duets. Does that make sense? If we had those 4 people, we could have them sing in 2s 6 different ways. Now, example 2 says, I want to be more specific, and out of 4 students, I want 1 student to be the lead in the duet, and one to be the background. How many possibilities are there for the duet now? So I have A, or Alice, Ben, Kat, and Dawn. All right, so let's say that Alice wants to be the lead singer. Who can Alice be the lead singer with? Ben, Alice can be with Kat, and Alice can be with Dawn. Dawn. Okay, so what if we want Ben to be the lead singer? Who can be his backup? Alice. Who else? Kat and Dawn. All right, if Kat is the lead singer, her backup can be Alice and Ben and Dawn. And if Dawn is the lead singer, his backup can be Alice, Ben, and Kat. Does that make sense? So there's how many possibilities here? 12. So when the order matters, like in number 2, we have more possibilities, right? When the order matters, we have more possibilities. You guys write this down?
Do it.
Okay. This is what we're learning today, is permutations and combinations. So permutations means that order matters. Put this in like big letters. Order matters. We're basically placing people in roles, okay? I want you guys to write that word too. Placing. So let's write some examples. Because order matters, I want you to think about a password. Does a password need to have the right order to work? Yeah, right? If your password is dog, but you spelled it G-O-D, is it going to work? No, so your order matters, right? For most passwords, like uppercase and lowercase even matters. What about for your phone number? Does the order matter? Yeah. If your number is 703 and I dial 730 instead, do I get the same person? No. So order matters for phone numbers. What about people with roles? I want you to think about this. So imagine if, let's say we're having a big, like every student wants to vote to see who's going to win class president. Okay? Order would matter there because whoever has the most votes would be the president. Does that make sense? So anytime you have a role like president, vice president, treasurer, things like that, that's order matters. Or if we have, like, if there's a race, first place, you can write that too, place. First place, second place, third, order matters, right? If you're first versus third, it's a big difference. Do you notice anything with all these examples? They all start with P, right? Password, phone, people, place, permutation, order matters. We'll continuously ask ourselves that question. Does order matter? All right, for combination, that means we are choosing a group. We are choosing a group with combination. Okay, you guys have this down? All right, grab your calculator. On your calculator, this is how we're going to input these numbers. The first number we're going to type in is going to be how many possibilities we have. The next number, number 2, says we're going to go to math, scroll over to probability, and we're going to choose either NPR or NCR. Do you guys see the difference between NPR and NCR? Well, one is permutations, one is combinations. Does that make sense? So we have to figure out which one we're going to use in these word problems. The last number is going to be the number that we're actually choosing. So for your first problem, we have let's say we're going to Chick-fil-A. Let's say that they have 5 choices of sauces. Could be more, it's probably more, but just an example. And what are the odds of you choosing only 2? Okay, that's what we're doing. How many different combinations can you get? So there's 5 possibilities. I want to choose 2. So grab your calculators. First, you're going to type your number. So what number of possibilities do we have? 5. Type in the number 5. Then we're going to hit math. Go over to probability. Look at our problem. Do we need P or C?
C.
C. So go down to number 3. Hit enter. Yours may look a little different than mine depending on the year of your calculator, but the process is still the same. All right, what is your last number? 2. Hit enter. And it does the work for you. So how many possibilities do we have?
10.
We have 10 possibilities. So my answer is 10. So this is basically what we just did. Instead of like listing out like heads, 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 tails, tails, this is going to pick out how many different possibilities we have without us having to write it out. All right, I want you guys to do numbers 2 and 3. All right, Channy, what'd you get for number 2? Did you do 8P4? Did you choose the C? All right, do it again, but with P. Did anyone get number 3?
I do.
What did you get?
6.
You should get 6 for number 3. Just make sure you're inputting the right thing.
It seems easy.
What did you get, Jenny? Good. You should get 1680 or 84P. Okay, so now we're going to do some. We're going to do some examples. All right, example 1. 12 gymnasts compete in an all-around finals at the Olympics. Part A says how many different combinations of gymnasts can win a medal in the all-around. Well, there's some important words here. The first one being combination. Do you think we're going to use C or P? C, because order does not matter here. They're just asking how many different ways can they get a medal. We're not asking who can be first, second, or third place. All right, there's how many total possibility of gymnasts? What's it say up here? We have 12 gymnasts and they are competing for how many medals? No, there's not many medals in the competition. There's 3. You have gold, silver, I keep spelling silver wrong. Gold, silver, and bronze. So anytime you see something about medals, remember that. Okay, so I have 12 and I want to choose 3 medal winners. How many different combinations of winners can we have? Type in your calculator. Let's practice this stuff. You can have 220 different possibilities. Let's look at letter B. If one gymnast wins the gold, one wins the silver, and one wins the bronze, how many possible outcomes are possible? Now does order matter? Yeah, it matters because one's going to win gold, one's going to win silver, and one's going to win bronze. So the order matters. If you're first, you're gold. If you're sixth, not going to matter, but we need to know how many different possibilities we have. So I have how many gymnasts? No, there's how many total? There's 12 total, and I'm choosing 3 different metals. So we have 12P3. Even though I use the word choosing, but order still matters. So that's why we use a P.
1320.
So you should have 1,320 different outcomes are possible. Any questions there? All right, take a look at number 2. 13 basketball players are competing for 5 starting positions. The players selected to start will make up the first team. How many different first teams are possible? Would this be combination or permutation? Does my order matter? That's what you're asking yourself. There's 13 players. We're choosing 5 people. Does it matter? It does not matter. It's not like we're counting first, second, third place. We just have 13 kids. If I choose the first 5, the middle 5, or 2 for the front, 3 for the back, I am choosing. It is not about order. So this is combination. There are how many total possibilities? 13, and I'm choosing how many positions? We're choosing 5. So there's how many total outcomes?
You get 1287.
You get 1,287. Any questions there? All right, let's skip 3 and 4. So number 5. In how many ways can the letters in the word hornets be arranged? And it says distinguishable permutation. Permutations. Do you think we're going to be using C or P?
So I don't know how many we use.
It tells you right here. What does it say? Permutation. Anytime they ask us how many different ways a word can work, or we can rearrange the letters, it's going to be permutation. All right, so look at the word hornets. I have how many letters in hornets? You have 7 letters, right? So that means if I scramble these letters up, they'll be in 7 positions. Does that make sense? Write that down. You have 7 letters. This is your letters. And these are your positions. Put that in your calculator. There's how many possibilities? What'd you get, Jeff?
5,040.
5,040 different outcomes there. That's how many ways I can rewrite the word hornets. Now this is where it gets interesting. Look at number 6. Number 6, same thing. In how many ways can the word Herndon be arranged? I have how many letters in the word Herndon?
7.
All right, we have 7 letters. But they're asking, can we arrange it so the order matters here? So we're going to use P. So we said we have 7 letters, right? And how many different positions can they be in? 7. But notice here, I have an N and another N. What if I flip-flop those N's? It looks the same, but isn't it in the same order? No, because my first N is on the last N, and the last N is now the first N. So we are going to divide.
Oh.
You guys see that?
Yeah.
We're going to divide always by repeat letters. I have how many repeat letters here? 2. So we're going to divide by 2 factorial. So we know that 7p7 we just did was 5,040. What is 2 factorial? You can do this in your head, guys. What's 2 times 1? 2. So what's 5,040 divided by 2?
Oh.
Is what?
Is
Yep, 2,520. That's how many ways, because we're taking out the repeat letters. So make yourself a note here that this 2 factorial was because of a repeat. Repeat letters. All right, off to the side somewhere, I want you to write this down. A whole different problem. We're going to do it. What if I had the word Mississippi? M-I-S-S-I-S-S-I-P-P-I. Let's count if I want to know how many different ways can I write this word. And I have how many letters?
2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
I have 11, okay? It's going to be a permutation because order matters. I have 11 letters that can be 11 different ways, right? You guys with me so far? That's what we just did. Okay? I have to take out the repeat letters though, right? So, how many times is I repeated? 4. So I'm going to divide by 4 factorial for the I's. What about my S's? So that would be 4. And then what about your P's? How many are those? 2. So I'm factoring out all of those numbers. Okay, in your calculator, you would do 11p11, and you would get a really long number. And then you would divide by 4 factorial times 4 factorial times 2 factorial. It's okay if you keep that all together. And for the sake of time, I'm not going to go over the answer, but if I see it, I may remember it. I think it was like, I don't know, 39 something, and then divide by...
Was it 700? Or I don't know. 7983360.
Yeah. That sounds right. Say it again.
79833620.
Yes, that sounds about right. That's how many different ways. Okay. The last part of this. If a problem has multiple permutations or combinations, we need to find them both separately, and then we multiply them together. So, I realized that you guys weren't even really alive for the whole Blockbuster scene, but your parents did it. So it says a movie rental business is having a special on new releases. The new releases consist of 8 comedies, 3 family, 10 action, 7 drama, and 2 mystery movies. Hold on one second, guys. You guys need me? There's more in? Right there. If you guys go back, yeah, just walk. Oh, to another door. It's a secret door. Okay, so it says, suppose you want exactly 3 comedy movies and 2 dramas. How many different movie combinations can you rent? So this is basically saying that you go to the movie store, they have all these different genres of movies, and we want to choose only certain amounts of certain kinds of movies. So we are choosing, right? Notice that word choosing. The order does not matter, right? I can pick up one movie, then another. It doesn't matter, okay? So let's do the drama or the comedy movies first. I have how many possibilities for comedy movies?
8.
We have 8. Good. It's right here. Okay, and I'm choosing how many? I'm choosing 3. Good. Then we're going to put a multiplication symbol in the middle. Now I have to choose my dramas. I have how many possibilities for drama? 7. And I'm choosing 2. Good. They told us there's 7 drama, we're choosing 2. In your calculator, I want you to do 8 choose 3. So 8C3. Do that by itself. 56? Okay, what about 7C2? 21. So now let's multiply both of my options together. 56 times 21?
1176.
1,176 different options of movies if I wanted to get those 5 movies. Now I want you to do letter B. Alright, so it's going to be on 2 different pages, so while you flip back and forth, did you guys have 10 action movies and you chose 4? And we're going to multiply that to 3 family movies and we chose 2. Is that correct? Okay, so for 10 choose 4, I got 210. For 3 choose 2, I got 3. So my total was 630 different movie options. Does that make sense? All right, let's try to do a couple of the practice. I'm not going to do all of them, but we'll do a couple. All right, number 1 says 20 horses competed in a race. In how many ways could the horses have finished in first place through third place? All right, that place word is important. Do we have a C or a P? We P, because order matters. Whenever we're talking about first place, second place, third place, Isaac, are you paying attention? All right, there's how many horses total that I can choose from? 20. And I want to choose how many for first through third place? 3. How'd you get that? So we have first place, yep, second place, and third place. So I have 3 options. So what is 20P3?
6,800.
Good. 6,840. Okay, a 10-person student council will be selected from 18 students at a school. How many possibilities are there for student council? Order does not matter here. It's not saying that we're choosing these 10 people from 18 and one's going to be president or one's going to be that or the other, okay? Order does not matter. So I'm going to have a C. I have how many possibilities? There's how many students? Nope. 18, and I'm choosing how many? 10. So how many people total could be on student council? 43,758. Does that make sense? All right, congrats, you survived. Kinda. All right, we're done with all new material. Your test is next class, so we'll check homework C. I will put an answer key for homework C on Blackboard. But for some of them, if the answer is like too easy, I'll just write check in class. Okay? But for most of them, it's going to be answers only. So when you do it, you can compare your answer to my answer. Okay? That'll be up tonight.
Using my answer, you're using not for yours.